So now we're gonna see the physics 2D reference. Unity's physics system lets you handle 2D physics to make use of optimizations available with 2D. You can use the following physics 2D components with Unity. So we have the Rigidbody 2D, the Collider 2D, physics material 2D, 2D joints, constant force 2D, and finally the effectors 2D. So we're gonna go into the Unity hub, and here I already have it. Already saved my project, but if you don't have, you can just click a new project and just click in 3D, and then you just click create project. So that's pretty much it, and then you are gonna have something like this. So I have the main camera, the terrain, and inside of the terrain as a child element, so I have this sphere, and these are all objects. So if I click F, let me see, if I click F, okay, and now I just only have this sphere here, and the project, as you can see here in the left corner, we have the project, and in the side inside of the assets folder we are gonna have the scenes folder, and inside I have the material. So I just pretty much right click, and then I can put new material, and you can pick whatever color you want here. Let's say, what is the color by default? So this is the color by default. If I just pick it and let me see, oops, no, it has to be in the scene. So if I just pick it, and if I just grab it and then I just drop it, this is the new color that is gonna adapt. If I grab this yellow one and I pick it up and I just drop it, then the game is gonna change to yellow. And if I do the same with the purple color, so obviously it's gonna change into this purple color. So if you go into scale, you can click here to make it bigger, so you can make it wider like this. So let me see, we have the main camera here, and then we have the terrain, and we have the sphere. So as you can see in the inspector, we have all the way down the associated script cannot be loaded. Oh, okay. So let me see, if we go inside of the assets folder, we're gonna have 2D texture that we created, and there's nothing. Okay, so we can just leave it like that, just delete it. So let's delete that one. And now if we go into the scene, we are gonna have the material. So we can also right click and then create a new folder, and we can just name it script for now, and we're gonna see a script in a later video. So we can just click script, and then we can just right click again, and then pretty much click grab the C# script. So new behavior, so we can just, oops, it's already set by default. And if you double click here, it's gonna send you to your let me see, to your Visual Studio Code. So I have it connected to Visual Studio Code, and again we are just gonna see for now this basic C# file. So the name is new behavior script, and this is the name that is gonna be here. So we have the new behavior script, and if you hear that noise, it has to be with my Armory crate. So let me check out if I put it in turbo. Maybe I should have put it on silence mode. So okay, it's in performance. If I put it in turbo, it's gonna be even more noisy. So I'm just gonna leave it in silent mode. So let's leave it like that for now. Okay, so this is C#, and here the name is new behavior script. So calling a mono behavior. Here we're using the public class, so this is public, so public class, and then the name of the file, that is new behavior script. So that is the one that we have here. And before to do that, we are using system.collections, using system.collections.generic, and finally they're using Unity engine. So inside of the public class, so we have the name of the file, say calling to the mono behavior. Then we're gonna open curly braces, and we're gonna have this void star So we can start having writing some code here, so we can pretty much have some if I don't know input something. We're gonna see this later. So I don't know, the page up or the space keyboard. So if you click that, then we're gonna do something. So we can do something like that. And then we have the void update. So this is where you wanna update. So if you already did something here and you wanna update it, so you write more code here. Okay, so we can just okay, we can just leave it like that for now. Yeah, save it. So we have that, and let me see now if we go into the sphere and more missing mono script. So I can, okay, so let me see, I can just grab this new script and just drop it here. Let me see if this works. No, oh yeah, I did. So pretty much you can just grab it here and drop it into this sphere, or just pretty much, let me see, just grab it and then drop it into the sphere. That okay, so I already did it twice, so let me remove this component. Okay, but still we have this one. Okay, so now what we are gonna see, let me see, script properties, move down, remove component, reset maybe. Okay, so reset, yeah. What we are gonna do right now is we are gonna see the Rigidbody. So let me see, we have, let's check out the Rigidbody too. So we are gonna go here, and in the inspector we have the add component. So you click here and we have the Rigidbody, we have the Rigidbody 2D, we have event trigger, and then we have new script, and then you would create pretty much create an add. So let's click create 2D. So cannot add component Rigidbody to sphere because it conflicts with the existing sphere collide derived component. Okay, so let's leave it like that. Let's put it let's have 3D cube. Okay, and let me see, so there's nothing here. Add a component, cannot add component Rigidbody 2D to cube because it conflicts with existing box collider derived component. Okay, so we have that. So Rigidbody 2, Rigidbodies enable physics-based behavior such as reactions to gravity, mass, drag, and momentum. A Rigidbody 2 is a 2D component you can use to enable an object to act under the control of physics. So here we have the introduction to Rigidbody 2D. Learn how to use the Rigid 2D in your project and how they interact with Collider 2D components. Then we have the Rigidbody 2D types. Choose which body type to use to define the behavior of the Rigidbody 2. Finally, we have the simulated property. Use this property to start or stop Rigidbody 2 and any attached Collider 2D and join 2Ds from interacting with the 2D physics simulation. So let's pick up the first one. Introduction to the Rigidbody 2D. You can attach a Rigidbody 2D component to a game object to control it with the physics system. The Rigidbody 2D shares a similar properties with the standard Rigidbody counterpart, but is adapted to a 2D development. For example, game objects have a Rigidbody 2D component attached to them, can only move along the XY plane, and can only rotate on an axis perpendicular to the plane. So how a Rigidbody 2D works? The Unity Editor's transform component defines how a position rotates and scales a game object and its child game objects within the scene. You change this component and updates other components which can affect where they render or the position of other colliders. Unity's 2D physics system can move colliders and make them interact with each other, so Unity requires a method for the physics system to communicate this movement of colliders back to the transform component. This movement in connection with collider is what a rigid body 2D component is for. The rigid body 2D component overrides the transform component and updates its position and or rotation it defines instead. So we have that. Then we have the collider 2D and rigid body 2D interaction. Okay, so any collider 2D component added to the same game object or child game object is implicitly attached to that rigid body 2D game object, causing the collider 2D to move with the rigid body 2D. When attached, you should never move the collider 2D directly using the transform or any collider offset. Move the rigid 2D instead. Moving the rigid body 2D provides the best performance and ensures correct collision detection. Collider 2D is attached to the same rigid body 2D won't collide with each other. This means you can create a set of colliders that attack effectively as a single compound collider, all moving and rotating in sync with the rigid body 2D. Rigid body 2D body types. There are three options for body type, which define the behavior of the rigid body 2D. Any collider 2D attached to that rigid body 2D inherits the rigid body 2D's body type as well. So if we go into the software, and let's say we go into the inside of the terrain, so you click in the terrain, right click, and then 3D object, and let's pick up a cube this time, and I want to see the coordinates of the spheres. 2740, so it's gonna be something similar to the cube. So right now it's in 0 0 0, so it's gonna be 27 4 and then 0. So let's try it out. Okay, so let me see. Yeah, that looks okay. Oops. 28, let me see. Yeah, that's fine. They're next to each other, so okay, so we can just maybe leave it at 20. Okay, no, maybe let me see if I can I don't know, 30. Yeah, 30. Y is gonna be 4. This one is gonna be, let's just leave it at 4 as well. So now C is gonna be at 0, and let's just put it at 0 as well. So okay, so pretty much we have this, so we have this cube and we have this sphere. So let's go into the assets folder, let's go into the scene folder, let's go to the material, and let's pick up, what is this? Okay, let's put a green, so we're gonna have green here. Okay, so now the cube is color green. So let's click in the cube again, and now we're gonna go into the inspector tab, and now we're gonna add components. So now we can pick up the, oh no, not to, it has to be the rigid body, just this one, the first one, rigid body. So we click here, and here we are gonna have in the mass, the drag, the angular drag. We're gonna have in the automatic center of mass, automatic tensor. Oops, let me check out. Oh yeah, automatic center of mass. So, and you can make this wider as you see fit. Okay, so we're gonna see this more in the physics chapter, but okay, it's kinematic, interpolate. So here is set to none, but we have interpolate, extrapolate, and we have the collision detection, discrete. We have some constraints, so let me see the constraints. Okay, so if you want to freeze the rotation, so if you want to freeze the X, the Y, or the Z position, so we also have the layer override, so include layers, nothing here, but we have everything default transparent, ignore raycast, so and exclude layer. We have the everything default transparent. Okay, so whatever. And the mass, so right now this object is weighing at 1 kilogram, but we can pretty much, I don't know, maybe 10 kilograms, so this one is gonna be heavy. Let's say if we want to create let's go into the script, and let's go, let me see, let's gonna go into the, we can grab this script and let's go into the let me see into the sphere. We have no behavior, so we can, okay, let's delete this. let's delete that. Let's delete that sphere. I mean that script file. But oops, yeah, let's script one. Yeah, let's delete it. And now in this folder we're just gonna have the, okay, we're gonna pick the C#, and we're gonna have a cube this time, so we're just gonna name it cube. And okay, so we can just double click and it's gonna send us to Visual Studio Code. Okay, and again it's pretty much the same thing, using system collections, .generic, using Unity. We have the boy start and the boy update. So here we will have to write some code, some if statement like this. If right now, if we go into the cube, right now is weighing okay, and 10 kilograms, and let's say it has a drag of 0. And now the sphere, so the sphere has a, let's add a rigid body to the sphere as well. So the sphere has a mass of 1 kilogram. So if you create again that these two objects are colliding, so obviously the cube is weighing in at 10 kilograms and the sphere is weighing in at 1 kilogram. So when they collide, this one is gonna have more force. So this is some physics, obviously. So this is the difference. That, but we can change that, and now the sphere would have, I don't know if we can make the sphere, I don't know, in now 20, so it's gonna have the double of the mass, and this is in kilograms. So the way that we would do it, so we will, this is for the cube. If the cube object collides with the sphere, okay, so move whatever, move the, I don't know, or yeah, move the object towards the right, towards the left, or whatever. But again, this cube is gonna have more mass, since we can add it here manually. We can put right now, yeah, the sphere is having, this is the, yeah, the sphere having 20 kilograms. So this is the rigid body here. Let me see, there are 3 types for body type, which defines, okay, so we already saw the, okay, the body type, the dynamic. So let me see the dynamic. The dynamic body type is the default body type for the rigid body 2D, because it is the most common body type for things that need to be moved, and is designed to move under simulation. All rigid body 2D properties are available with this body type, such as finity, mass, and drag. Okay, so you also have drag here, and you can, I don't know, modify it to 10, 100, whatever. Let's leave it at 10, and this is for the sphere. Okay, so let me see, rigid body, okay, per se, simulation. All rigid body 2D properties are available with this body type. So okay, a dynamic body will collide with every other body type, and is most interactive of body types. It's also the most expensive body type because of its dynamic nature and interactivity with everything around it. So okay, do not use transform component to set the position or rotation of a dynamic rigid body 2D. The simulation repositions a dynamic rigid body 2D according to its velocity. You can change this directly via forces applied by the scripts. So again, we're gonna see later on, but in order to modify, we can do it with the script. So this is a script, so writing code in C# would be considered a script. So the body type is dynamic. Let me see, body type. Okay, so collisions, drag, blah blah blah. What else do we have here? Let me see, interpolate, kinematics. Okay, this is the stand. Okay, no, this is the new material. Okay, that's fine. So we have the dynamic available in rigid body 2D properties. Okay, and then we will see some properties: the body type, the function. Select to set the movement behavior and collide it to the interactions of this rigid body to these components. So we have dynamic, kinematic, and static. So this is physics. Then we have the material, simulated use, auto mass, linear drag, angular drag, gravity scale, collision detection. And inside we have the discrete, continuous. Then we have also sleeping mode, interpolate, constraints, layer overrides. And this is pretty much all that we see here. Interpolate, so we have non-interpolate, extrapolate, so we also have collision detection, discrete, continuous, dynamic, continuous is speculative, and then we have the layer override. So this is pretty much all that we have for the rigid body.